Everybody, you guys are. So we will be continuing with our journey with Swift. So last time we learned about enums. Enums are basically enums are basically all possible values a variable can hold. So then we have different cases represented by the case. Now the case statement can be used with enums. Then what we studied was how to so the another advantage is when we declare the enum, the memory does not get assigned. When we create an instance of it, then the enum is created. The memory is assigned to the enum, and then we also studied how we can associate values with enums. And this is like a special advantage. Now these values cannot be accessed until and unless and until we perform binding. Then switch. Now switch. Uh, so like till previously we had learned that beside the switch we need a number, but it's not that thing. We can also use switch with an enum. Um, Remember, besides the switch, we need to pass the instance of the enum, and case is basically like a keyword. It can be used in switch. It can be used for pattern matching. Pattern matching, that is if else, guard case, while case. And remember, while using switch, always we need to take care that all cases are converted. So default is mandatory here. So until and unless we bind the associated value, it remains protected. Something like that, which cannot be accessed directly. Now today we are going to study about structures. Now structures are the basic building blocks of uh, like without structures there is no uh, there is like without structures you cannot have Swift. So like it's like the most important thing in Swift. Um, Now Swift. Now when to use Swift? Now what is the advantage of using Swift? What is Swift versus struct? Sorry, what is the difference between a structure and an enum? And how is memory allocated to Swift? Like, is it like a reference type, or is it like a, even though we say we are creating an instance of an enum, remember it is still a value type. That is, a copy will be passed. It's always passed by reference and not passed by value. It's still a type. Type value basically something which is stored on the stack. Like a copy is being passed whenever you try passing it. Just okay. Now structures. Structures are complex data types, meaning that they are made up of multiple values. You then can create an instance of struct and fill in its values. Then you can pass it around as a single value in your code. For example, we could define a person struct type that contains two properties, clothes and shoes. Now, the way it's defined is it is a complex data type, and so using struct you can have multiple values. Enum is basically all the possible cases that that particular variable can hold. Okay, let's write structure basically multiple. They are uh, mm, multiple data values struct. Now declaring a structure, we use the struct keyword. Then we get the name of the structure. And then we write curly braces, including, and then we give the properties. You see here, let's so right now we are just declaring the blueprint of the structure, and then there is no need to mention semicolon. It's optional insert. Now we are going to create. So to create a structure, create an internal structure where the actual memory allocation takes place, we need to do something like it can be anything where so then we can say person no name name then you need to pass a string this Mr. Server. Closes and then choose right. Now here now then we can do print. We can do container dot. We can let's make this as s. This is like compile time thing, right? Then let's print dot oh this is this one is what happened? Oh it's just no. No. Why is it preparing to run? Okay, it's still running. It's not running. First time. There you go. You have pants and Gucci. You know what? Let's let this not run out needed. So what else is pending? Not needed. This thing. This slash. Cannot find all. Let's this thing is wrong. There is some function also. Is there a shortcut way to do comments? Okay, let's leave that thing. Okay, when you define a struct, it makes them very easy to create because it automatically generates what called the member-wise initializer. Now let's think more about initializers. Now, what are initializers? Initializers are basically a method that gets called whenever a new instance is created. Remember, this is like calling a method, right? So then what happens is now there are type initializers are responsible to make sure that instance is used. So the main goal of this instance is to make sure that it has some values and it can be used. The types of initializers. So there are different types of initializers. So let's the default initializer. So this is basically the default one. It's also called as members wise initializer because we are going to initialize it by passing individual members, like we are going to specify. So this is, so let's write initializer. Initializer is a special method is called when we create an, okay, it's a special method it's called. The second, there are different types of initializers. So the first is default initial default initializer or number wise initializer. So this is, we have already like we have already done. Then let's then we are going to do something called as using init. That's a required initializer. Basically, no. Okay, then we are okay. So first is basically our default initializer, and then next is this is automatically called, right? Then is convenience initializer. Okay. Okay, then we have something called as convenience initializer. Here's the keyword convenience. Then there is something called as designated as a designated initializer. This is basically using the keyword init, right? Using the init. And then we have then we have something called as variable or required initializer. And required initializer. This is mandatory, right? This is mandatory, and if the subclass generates, then it has a required initial. The subclass must implement the initial as well. The inheriting class has to implement this as well. That is failure. What is my This is basically what if my when my init has an optional return. Init has an optional return. No, optional return type. Okay. Okay, now, no, not class. Structs now. If you assign one struct to another struct, flip copies. Okay, now this is something. Now remember, now what if I do when Taylor to assign it to Taylor. Now if I do my if I change something like I say Taylor to what clothes is something is a shirt. Now print Taylor dot shirt and print Taylor Taylor two dot this is clothes. Now say okay. Now see, even though we have changed here, so whenever assigning it to a new variable, a copy is passed. And when we assign copies, copy of the copies. Okay. Okay. Now then, there's something else. Oh no, not classes. Now okay, we can have a function as well inside. Let's have a function. Remember, this is a property. This is describe function. Print. So just name the reference to what I'm saying at this method available as online. Just do it. That's nice. Perfect. There's one more thing to know that but can't see in the code when you write a function. Okay, this is called as a method. Okay. This is referred to as a method since using instance. Okay. Now classes. Now Swift has another way of building complex data types. Classes. Now the difference between structs and classes is classes are passed by reference and structs are passed by value. Remember. And classes so active. Is there a mandatory thing to have in it? Classes. Now Swift has another way of building complex data types. They look similar to structs but have a number of important differences, including you didn't get an automatic member-wise initializer. Okay, there is no default initializer for structs. You will have to do it. You can define the class as being based off another class. You can perform inheritance. The difference between struct and classes is the OOP things can't be done. For example, we can't perform polymorphism, we can't perform inheritance, we can perform something always prototype oriented something, but not um, not protocol oriented language, but not inheritance. The core founding pillars of. Okay, let's see. Let's write classes. This is basically OOP feature. Classes are also like structs. Only differences they are reference based type based, and also classes reference wise. Yeah, there is no number wise or default initializer. There is no default or number wise initializer. Invoke class string parentheses declare properties strings and string and creating a reference. Let's remember I need the initializer, right? Init. So init. No, annotation. Type annotation is missing. Not the result type by type annotation. Oh, we need to mention that this is like that's because we have not initialized it yet. Reference and reference and this. Now let's study the difference between what is going to happen if I if no reference tools. I say here the entire this is pass. Now I want to do something like reference dot notes equal to, let's make it as T. Now it's to print reference dot notes. When we do and run this, see the magic. See, t-shirt has come. This value has changed now. That is because it is passed by value. Now functions. Let's saying we can have functions as well. Okay. First, don't write func before your init method because it's a special method. Yes, because the parameters are being passed are the same self dot. Okay. So it requires that all optional properties have a value by the end of the initializer or by the time the initializer calls the method, whichever comes first. Now class inheritance. The second difference is classes and struct is you can do inheritance. Okay, so this is single. Yet, how can we do inheritance? Oh, so yeah, inheritance is basically like parent and child relationship, and then there are certain rules. Class single. Let's have two properties here. then marriage. This is let this be. Then I have class. This is singular, right? And then what I can do is plus country singular inherit. This country singular inherit from singular. Now let's this class have its own name. So singular. What can I say? Okay. Let's now what you can do is I can create a reference of child and then use the above details. So I can say country single name and it was I say this is and then I say it's 30 20 whatever. And I do print child dot h 20. Okay. Now I can override a function plus entail. So I have a function is overriding is basically same function type but different functionality. This is again a OP feature. I guess this has to be present in both. It's going to override. Let's go. Oh, there is a function singular. This is function singular. The structure will be the same. Organize name and then I say not an overriding and then print it's an overriding function, right? The moment I call it or this reference, the moment I call the reference it will override it. Now it will dot nothing. This is going to print G1, right? So okay, now to make things more complicated, we are going to define a new class called as heavy metal single, but this time we are going to store a new property called noise level. Defining our knowledge, this causes next to scream down the microphone. Now this causes a problem, and that's one night to be solved. So it wants all non-optional properties to have a value. A single class does not have a noise level property. So we need to create a custom initializer for heavy metal single. Is going to create a new class and then okay in the class you put for non-options. It might work here, it might not. Playground is an extended version, right? I'm going to extend it. Then yes, and init initialize this. Super init isn't called on all paths. Now, okay. Now let's see. Our single class doesn't have a noise level property, so we have to write a custom initializer that accepts a noise level. That initializer also needs to know the name and age of the so it can pass to a super class. Passing on data to the super class is done through a method called you can make method calls initialization until we have given all your properties values. So we need to get our own property first and then pass on other parameters for the super class to use. What is it trying to do? Okay, now notice how this initializer takes three parameters, then calls super.init to pass name and age to the single superclass. Only after its own property has been set. You'll see super used. Okay, so now there is something with super classes. Values versus reference I have already told you so. Property observers. No, I have done. Oh yeah, there is completed properties and this is important. Oh, I haven't got that yet, so I won't go ahead. Let's first check this thing about super keyword. What happens? Now let's open AI. Why do we need to? Yes, super in strings. A super keyword is used to refer to the superclass. It allows you to access the property methods and initialize that are inherited from the superclass, especially when you are overriding them in a subclass. Calling a superclass method. Why I need a super dot init? Oh, so yeah, the problem is there is some issue now here with the super keyword. Okay, now it kind of will think that it's I'm doing the overriding of the, even though the parameters might be different, or then doesn't it understand from the structure. This one thing, not in single, no, not in single. In heavy metal class. Where is my heavy metal here? And this is going to inherit. Now let's say something with super init. Super init is used to indicate it is the child init and not parent init. Something like that. I guess that should be the reason. Super when a supposed to call the designated initializer of its, it is mocking the parents in order to set up the inherited properties before setting up those classes. Now when you supply a class that has the designated initializer, the subclass will call that initializer to ensure that superclass's properties are initialized before the subclass class initialize its properties. So even though breed is, I will have to initialize. Okay, but then when I call the reference, I have to call the designated initializer of the super. Okay, first let's say the use of keyword super. Super is basically, yeah, it's maximum. Super. Since it super is a keyword that is used to refer to the superclass of the current class, it allows you to access properties, methods, and initializers that are inherited from the superclass. Let's say anytime I can do super. Okay. So let's first, before doing or initializing anything, let's have this commented for the timeline. with the super keyword. What does it do? Super keyword can call the parent. It is used to refer to the subclass, the parent class of the current class. It allows you to access. Okay, so if you want to access parent methods in the reusable, if you want to access parent methods in reusable keyword. That is super dot. Okay, just to print. So print name the parents page. Expect now use of print refers to instant as rather than global. What is the calling a super class initializer? Uh, so if I want to access super class properties, okay, I need to where's been. So now this is something like basic accessing properties without getter and setter. Without getter and setter, I cannot access what I am getting. Next, use of print refers to instance. So let's like remove this. It's super. Okay. Expected parentheses, expected func, expected parameter name. By name colon. This is why is this an error? This is an error because super can only be used inside methods or instances of a subclass to access pub. Okay. This can be only used inside methods or subclasses. What is trying to say? Okay. 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 Use inside methods. So I think what's the advantage? What do you mean by context? Like, what's the advantage? So is it like I'm calling something, but doesn't when I call that function, then the statements inside it are executed, right? Is it like we properties inside class not executed the memory is allocated once the instance is created. Is it a method? Media define a structure. Yeah, entity said the memories are allocated in the methods. So is super a method? So what it's trying to say is super will not be called if it's just written. Okay, so super dot h will create an parent instance or something. If a subclass, super class of the parent class, so I'm going to access the parent properties. Then why should we mention it inside a method or a function? The thing is, if I write directly, this is not getting executed. I'll have to call something on it. Methods are invoked using the reference, right? Yeah, we won't be able to run this. This will not work. Classes are blueprints. can be initialized. Let's have it on next line. Initialized. The execution need to be called place super in a method and supervise into one to just do a random test in the parameter, and this is now for concept of the print on the decimal. Even if I rated print something, it should not work properly anymore. Should give me an error. See, it expects this to be in a function if I write here. This won't call anything. Yes, now it's the instance created. Let's run here. Super.h. Let's run. This is super. These are like blueprints, right? They don't work unless. Why is my? Oh, I need to call this method. Come here. Let's do single dot. Does it take? There's nothing past it. Instant member test cannot be used on type. I'm not creating an instance, right? Oh, I'm not initializing anything. Did you mean? What he's saying is, let's. Yeah, you can come properly. Did you mean to use a value of this type? No. The thing is, that instance thing has to. There should be an init, right? Then. Yeah, the init will be there. If I'm trying to access it. Because I'm going to assign parameter to it, so. This is creating an instance of the parent, not the child. Oh, I'm using the wrong thing. I say I need to use reference child dot something. Yeah. Now it should work. See, this is super. Okay. And then let's go with. Now then, what we were studying. Then let's. Oh yeah, then we were studying about super init, right? Now what's that? Super init. Why super can be used outside of a method? Initialize the super init. The class countryside singer override function sing. This is super.h. What does super do? Now, what is the need to have a super dot in it? Super dot in it is like is for parent in it, something like that. Yes, you are correct. Now, since if when you subclass a class, the 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 subclass or the child will inherit the property from the parent. If the parent has a class initializer that is a custom in it, the subclass needs to call the parent class to make sure that the parent class is property initialized before the subclass performs its own initialization. Okay, so before performing this initialization, I'll have to initialize the parent thing because I'm going to use age, right? So before, okay, if I have a, yeah, that will, I will be having that in it, right? First, the super call will be made and then okay, so the genre property is going to get initialized afterwards. Now what is h colon h? Also, I'm passing 30 right from outside. So what I'm trying to do is I'm trying to access the parent. Why is he doing? Super dot init is to call the parent class initializer from within a subclass initializer. This is necessary when the super class is initializer, then needs to be invoked before the subclass can complete its own initialization. Let's go to more detail and understand how super dot init works and why it's important. Now why super dot init? In Swift, when you subclass a class, the subclass inherits the properties and methods from the parent class. If the parent has an initializer, then the subclass needs to call the initializer to make sure that the parent class is properly initialized before subclass perform its own initialization. Okay. Why do we need to initialize the parent first? Still or not? Subclass is built on top of subparent class. The subclass depends upon the state of the when you create an instance of a child class, the script needs to make sure that the parent class part of the object is initialized before the subclass and properties that so that can be used. Also, what he's saying might there might be an what he's trying to say is to make sure the properties of the parent can be used in the child. We perform super initialize something like that he's trying to say, I guess. Yes, exactly. Okay, so what is going to happen is the moment I do this, but isn't that like creating a, oh, now there will be a confusion, right, which init has been, because now if I also have an init over here, then what? I'm not overriding anything, I'm just trying to use, if I have two units then it will get confused. Yeah, so I'm not right overwriting it. So now I need the. So I'm going to do okay. Seventh. I'm passing the same thing as the parent is. Let's change this. No, let's add something else. Well, parent name. Then this is a string, and then I come here, change this to parent name. Let this be string. And this is same dot parent name equals parent name, and then I'm doing that super dot this is right, calling the parent in it. Other than I need to pass an age as well, so this will age delete. So here I'm going to pass, this is going to be name, let this be age. So now when I come to the call, where is the call? Okay, this is name, and then have age, and then have other parameter. Yeah, randomness. Metallica, or anything which you know. Property, so these are collectives. Okay, these are basically now I haven't talked about property observers. So then something, this is okay. Oh, it's almost done. I'm almost nearing protocols. That's good. Okay, this is okay. Now access control. I can have public, internal, file private. It's just how you want to access it. Properties. Yeah, this is done. This is done. Only property observers and computed properties are there. And then static. Access control is done. Okay. This is protocol extensions. And this is. And then I'm going to UI, right? Okay. Then is, I guess, UI. Which pages is this? It's right now I want something 100. Oh yeah, then I'll be driving into Swift UI, right? So that's okay. That is nice. Let's move on. Somewhere we have 140 something. 140. Oh, let's yeah. Up. Why am I going down now? Okay, that's all for this lecture.